Hey, this video was supposed to be out roughly 3 weeks ago. That didn't go as planned. Well, yeah, I initially planned to have this video out before 2026 and I just didn't get to it, partially by my own laziness and partially because what I wanted to implement took a bit longer than I expected, because the topic we're going to talk about today is refactoring. Now, if you don't know what refactoring is basically keeping the external of whatever you're programming, in this case, the game, completely intact while changing the entire interior to be, well, optimized, better, faster, easier to understand, easier to expand. And that's just what I did. Now, the way I did that was I rewrote the entire code of my character controller into what is called a finite state machine. Now, you may very well be confused what the fuck a finite state machine is if you have never had anything to do with game development. Let me explain. And for that, we're gonna use beautiful Photoshop because I love drawing shit and explaining in Photoshop. So what it does is we take our code, in this case specifically our player controller, and split it up into different states that are completely independent from each other. An example for that would be, I have my character, which is, my little stick man right here. He has one state right now, and that state is being idle, which is the state of doing nothing. And then, for example, when I input a walk command, my player character changes, because now he's walking, which means we transitioned to a different state. Similarly, we could also transition back into idle by just stopping to walk. That's kind of the simple gist of a finite state machine. We can take pretty much everything our player character does and associate it with its unique state, and therefore completely separated from the rest, meaning we turn our code from something that is, well, how it previously was, which is this script being a very rigid 499 line script that pretty much did everything, into something that is a lot more modular. As you can see here with the player character, we have different nodes for, I think, 19 different states, which I broke down my code into. Why would I do this? The simple answer is it's a lot better for the future of what I want to do with this project, because extending the 499 line long main script is starting to get a pain in the ass as it is right now. Every time I implement a new method, I have to completely cross-reference it almost over the entire script just so it can't break something around 4 different corners. And especially in the future when I want to implement animations and sound effects, it's a lot easier if your code is kind of sectioned off into different modules. In this case, the modules are the different states. Because if I ever need to replace something, or I want to remove a feature, or similarly, with how it is right now, you could basically think of my code as a giant wall that is completely solid, and if I want to take out a chunk, I have to break that wall to take out a chunk. And if I want to put something else in, I have to, first break it, then put the new thing in, and then I have to clean up all the gaps. That's a pain in the ass. Instead, with the way the code is right now, it is practically something like a wall made out of Lego bricks. It's very easy to open up, take out a brick, and replace it with another brick. It's also very easy to just stack another brick on top. How exactly did I split up my code, and how exactly did I implement the finite state machine? To show it, the finite state machine is pretty simple. It basically consists of only 2 files that are behind the entire logic of it. One is the state class, which serves as a template for every other state, and the other is the state machine class, which is the class that is responsible for switching between states and connecting to, in my case, the player character. Let's go over the state first. What does every state need? As you can see here, there's only 3 functions in the state and 1 variable. That 1 variable being to the state machine, as every state is, well, using the state machine to transition into another state. Therefore, we can implement it here and have every other state inherited. Additionally, the 3 functions we have are enter, exit, and update. Enter and exit are pretty self-explanatory. Enter is a function that gets only called once when you enter the state. Exit is the polar opposite. It's only getting called whenever you exit the state. Now, why would you need an enter or an exit function? To give an example, let's say I have my jump and I want to implement sound effects for it. You know, when you jump, you kick off the ground. That is a specific sound effect, which is, for example, something you can put in the enter function, as it only happens at the start of the jump. Whenever you kick off the ground, you play the sound effect for jumping. Second of all, we have the state machine. The way it's implemented, it's also pretty simple. The first thing it does is whenever the project gets booted up or in the ready function, it does an iteration through its children, which the children of the state machine, if I open this up again, as you can see, are the different states. So what the state machine is doing when the program is started is it's going through every single one of these, and basically it's creating a collection of all the state. In the case of Godot, a collection would be a dictionary. So we have a collection of our states, and we do another thing, which is setting our initial state, which if I go into the state machine, you can see right up here, we have a initial state export variable where I can set whatever state we want to start off with. Then we have 2 other functions. One is the process function, and this one is connected directly to the last function of the state, which I purposefully didn't talk about because those are connected. The process function, if you know about Godot or other game engines, is a function that is basically called every frame. Anything that has to do, you know, with movement, physics, that isn't a one-time thing, but that is continually checked and applied, goes into the process function. In our case, the first thing that's only for myself is a debug property. So in my debug menu, I can check which state I'm in right now, which was a big help for the implementation. And the other is, if we have a current state, which we should always have, we run the update function in the current state, and we pass on our delta, which that is the last function of the state, the update function, which is basically ran every single frame. So in case of, for example, our walking from earlier, we would just continuously keep walking as long as we hold the input. And it's continuously checking if we still hold the input, and if we let go of the input, we stop walking. You know, I can show it off even right here. As you can see, the majority of the walking script is inside the update function. And then down here, I have basically created my own extra function where I do all the transitions between the state. But for example, if my character velocity's length is 0, meaning I stop walking, I, for example, revert back to idle. To give a practical example of how states were implemented, let's think of a situation like this. Let's say this is our imaginary ledge. And what we're doing here is we have our character up here, you know, our little guy. And what our character is gonna do is he's gonna walk forward, jump, fall down to the ground, then catch his landing with a roll, and then continue walking. How would I, for example, break up this scenario into different states? Well, the way I did it is, let's say I start off with this state, which is completely standing still, being idle. Then I start moving, which transitions us into another state. In this case, being the walk. Then, once I hit the ledge, I, decide to press the jump button, and we're gonna hit a jump. Now, this is one part that is a bit more interesting than the other ones that, might seem trivial, the jump is actually only the state for when my character has a rising velocity. I could have done it so that my character's jump state is anytime the character is in the air, but that made implementing certain things like, grabbing ledges or vaulting kind of difficult. So instead I decided to split up this into two different states, one of which is the jump and one of which is then the fall whenever we have a negative velocity. And the fall and the jump, while they are directly connected, are also, separate from each other, because in this case, we could also have chosen not to jump and just run off the ledge, which would have then transitioned us from walking straight into falling. Then, when we finish our fall, let's say in yellow we do this, which is our roll. This might be hard to read. I shouldn't have chosen yellow, but it is what it is. Either way, we're gonna finish our roll by transitioning back into idle, and then once we finished idle, we're gonna transition right back into walking. And that's, for example, a practical scenario of how the state machine would play out. And if I were to showcase it in kind of like the network view of the state machine, let's open up a new file. Let's keep the same colors. You could say, for example, I have the idle right here, which is my starting state. And from the idle state, as I showcased, I could, for example, go into the walk state, meaning these two are directly connected. And then from the walk state, in my last example, I, for example, wrong color. And then from the walk state, like in my example, I went right into a jump, but that jump isn't only connected to the walk, but it's also connected to the idle. So I could just jump when idling, or I could jump when walking. And if we add the other things here, for example, I have my fall, which, if I pick the color, my fall is right up here. And it's also connected to the jump and the walk, as both of those can transition into it. And if you were to continue this example, you would get something that resembles a network where you have all your different nodes and their interactions to another, which would be something like this, for example, where you have your central node, in my case, the idle, and then everything connects to each other, and you just logically transition along these nodes, which lets you skip certain conditions. For example, if I'm in the jumping state, I don't have to check if I'm in the air because, well, by jumping, it is already implied that I'm in the air, which saves you a lot of headaches when it comes to, implementing different methods. Now, there are problems with the state machine that happened when I implemented it. One of which is there are certain mechanics in the game that cannot be factored out into a state because they are way too universal. One of which, for example, is if we look at our character from a top view, the camera. The camera has to be able to be moved in the idle state, the walk state, the jump state, the falling state, when you grab a ledge. Basically everywhere the camera is still able to be used, which means it makes no sense to factor it out into its own state. So instead, the character, well, in my case, the player script, still contains the camera. For example, right here I have my function like controller camera, and other functions like deturning, which also is camera related and doable in every different state, is also factored out into the player script. So these are what you would call decentralized mechanics because they're accessible everywhere. Meanwhile, our network right here would be a centralized finite state machine. You can also have a decentralized finite state machine, but it wouldn't have made sense for a parkour player controller. The way that would work is you have your different nodes, but instead of being rigidly connected to each other, basically you have a bunch of dots, and every dot can send out a signal that can be received by any other given dot.
that makes a lot more sense for something like enemy design, for example, where an enemy has to be in a, in an idle state. Let's say we have our big bad devilish enemy here. And, for example, right now it's idling, and then when my player character, for example, gets in range, it then starts to chase the player character because it's entering the aggro state. And then maybe, if you build it like that, you have different enemies that also co-aggro, because this enemy getting aggro will send out a signal to other enemies, and those other enemies, let's get them little faces down here. Yeah, those look absolutely beautiful. Those other enemies now will also swarm my player character.
So, state machines are not only applicable for characters, you can put a state machine on anything. You can put a state machine on breakable objects and have the state be, like, unbroken, and then whenever it's hit, it gets broken. You know, it's a concept that is universally applicable and universally always pretty much really good because it's easy to expand upon, like I explained earlier. And yeah, it's pretty interesting. It's a big pain in the ass, but at the very least, everything works as it should, which I can showcase right here. So, and my character can walk. I can, crouch walk, I can slide, I can jump, I can do my little, vault up the ledge, I can springboard, I can jump over this. Now everything works. The one thing I did change though in the process of rewriting the code, but it's not big enough to really be a new feature, but I gave the wall run a slide rotation, which seems trivial, but was also much more a pain in the ass because in Godot's documentation, the rotate object local, which you would think would be exactly the thing for this, doesn't actually work for this rotation, and I had to do it a little bit of a different way, but yeah. Other than that, as you can see, it's the exact same game, despite being not alike at all when it comes to the actual code base of it. But I'm very happy with it, and I'm gonna continue building on it. And since I have the new feature already implemented, the next video should not take as long, especially if I forego writing a script like I did for this video, which might make it a more messy video, but I'm not a video editor, I'm not a YouTuber. I just do this shit to have my game be documented somewhere, and so I can show it off to people, because I think the journey is as interesting as the destination finally. And while I could make it, a better video, I'm happy with the way it is, and I want to have my main focus be the actual development and not, writing scripts, editing videos, and losing a bunch of time on that, basically. So yeah, that's about it for this video. I hope it's understandable. I hope it's interesting for those people that are into game dev. For everybody else, I think this is probably a very, very dry topic because there's no new features, there's nothing really to be excited about, there's nothing really to play in a different way. It's the exact same game, but I still did a lot of work to get it to where it is right now. And yeah, either way, new feature is there. I'm gonna talk about it soon. New video soon. See ya.